Maths is awesome, maths is fun, maths is there for everyone.
Hello Year 8 students. Today we're going to be looking at exercise 7H and how we can apply some straight line graphs to different simple situations. So let's look at our first question. Excuse me. A hiker walks at a constant rate of 4 kilometres per hour for 4 hours. So, key part here, they walk at 4 kilometres per hour and they're going to be walking for 4 hours. So we have to draw a table of values, and instead of having an x and a y-axis, we're going to use t for time and d for distance. So let's look at our table. The first part says, how far would they travel if time was 0? So how far would they travel after 0 hours? Well, after 0 hours, they have travelled nowhere because they haven't moved. Now, we know they walk 4 kilometres per hour. That means they walk 4 kilometres every hour. So after 1 hour, they have walked 4 kilometres. After 2 hours, they've walked 2 lots of 4 kilometres, which is 8 kilometres. 3 hours, they've walked 4 kilometres an hour for 3 hours, 4 lots of 3, 12. And after 4 hours, that's 4 lots of 4 kilometres, which is 16 kilometres walked. Now we need to draw the graph. So to draw the graph, we need to actually look at our axes and figure out which one's which. Well, our time axis always goes along the horizontal, the bottom row. And distance is going to be our vertical axis. And one way to think of that is often x would have been in the top row, y would have been in the bottom row. So x is going to be replaced with a t and y is going to be replaced with a d. Now, as far as the time axis goes, we know we're graphing from 0 all the way out to 4. So if we're graphing from 0 out to 4, 0 is going to be there. I'm going to actually put 1, 2, 3 and 4. I'm going to put an extra space in there. So each square box, if you like, so that square box from there to there would represent 30 minutes. There's another 30 minutes. And between the two of them, it adds up to an hour. So now, we need to look at our vertical or our distance axis. Now, I know the distance goes up to from 0 up to 16. So if we're going up to 16, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to go up in lots of 2, I think, would be the best way to do for that. So let's just get rid of that. Going up in 2s. So this will be 2, 4, 6, 8, 10, 12, 14, and 16. Now I'm going to plot my points. The first point I want to plot is the point 0, 0. The second point, after 1 hour, they've walked 4 kilometres. So go out 1 hour, up 4. After 2 hours, you're up at 8 kilometres. After 3 hours, we're up at 12 kilometres. After 4 hours, we're up at 16 kilometres, and then I will join them. And there's my graph. Now, let's just shrink that a bit. Part C says, find the rule linking D with T. Now I can do this two ways. I can use the table from part A, or I can use the graph from part B, and I'll show you both ways. If I'm going back to the table from part A, remember, it was many lessons ago now, where we looked at the Y row and we said, what is it going up by? Well, this is going from 0 to 4, then 4 to 8, 8 to 12, 12 to 16. It's going up by 4. And we also said in the x row, what's the number underneath 0? In this case, the number underneath 0 is 0. So the rule would have been y equals mx plus b becomes y equals 4x plus 0, or just 4x, because we don't need to write the plus 0. So if I want to link a rule with d and t, remember y has been replaced with d and x has been replaced with t. So if I look at that, I can say y is replaced with d, x is replaced with t. My rule is d equals 4t from this section here. Now I said we could also do that from the graph. If I wanted to do it from the graph, it's a little bit trickier, but we can do it. We need to figure out m, which is the rise over the run. So I need to take a couple of points. I'm going to choose two random points. I might choose this point down the bottom and this point here. Draw in my right angle triangle. We've done this before with graphs. Now my run, my crossways distance, I'm going from 0 out to 1, so the run is 1. But this is where it gets quite tricky. You don't count the boxes because there's 2 boxes going from 0 out to 1, but remember each box represented 30 minutes. Going up, there are still 2 boxes, but going up, we start at 0 and we climb up to 4. So it means I've climbed up 4 units. So the rise is 4 and the run is 1, and 4 over 1 is 4. Where does my pink line cross the y-axis? Well, it's not a y-axis, it's a d-axis. This is my d-axis, my vertical axis. Where does the line cross that? Well, it crosses it here. And that is at 0. So y equals mx plus b becomes y equals 4x plus 0, which is exactly the same as what I got before when I used the table. So it doesn't matter which way you do it, you're going to get the same answer. Now, part C says, use your rule to find the distance travelled when you walk for 2.5 hours of walking. Well, if I use the actual rule, the rule says the distance that you travel equals 4 times t. 4 times, if we're walking for 2.5 hours, we put into the calculator 4 times 2.5 and we will get 10. So, if you walked for 2.5 or 2.5 hours, you would have walked 10 kilometres if you're using this model. And if we wanted to check that, if I go out to my time, 2.5 hours would be halfway between 2 and 3. Goes up to there on the graph, which comes back to 10. So you would have walked 10 kilometres. Next part says to use your rule to find the time taken to travel 8 kilometres. Well, if we're going to travel 8 kilometres, the rule is d equals 4t. So it becomes 8, because the distance that we're travelling is 8 kilometres. 8 equals 4t. Now, if that's the case, we're going to divide both sides by 4 so we can get t by itself. And I end up with t by itself, and 8 divided by 4 is 2. So 2 equals t, or better still, I could write t equals 2. So it will take me 2 hours to walk 8 kilometres. And again, I can check that from the graph by doing this. Go to 8 kilometres, come across to the graph, then drop down, and hopefully you can see that that's taken me 2 hours. Let's try our second question. Now the second question says, the initial volume of water in a dish in the sun is 300 millilitres. The water evaporates and the volume decreases by 50 millilitres per hour for 6 hours. So the water that's in our dish is out in the sun for 6 hours. Water's evaporating. We want to know how much is left after 6 hours effectively. So we have to draw our table. Now, to start with, after 0 hours, we haven't lost anything. The sun hasn't worked. We just got out there. So there was 300 millilitres in the dish originally. So after 0 hours, there's still 300 millilitres. But we are decreasing or losing 50 millilitres every hour. So after 1 hour, we have to do 300 take away 50, that's 250. So after 1 hour, there's 250 millilitres left. Next hour, we had 250 and we've lost 50, so that's going to be 200 millilitres left. And you can see we're going down by 50 every hour because we're losing 50 millilitres every hour. 200 take 50, 150. 150 take 50, 100. 100 take 50, 50. 50 take 50, 0. That actually means after 6 hours there's no water left in our dish because it's all evaporated. So now we need to plot this. Remember, instead of an x-axis and instead of a y-axis, we now have t and v. So instead of the x-axis, we put a t. Instead of the y-axis, we put a v. The t-axis starts at 0 and it goes out 1, 2, 3, 4, 5 and 6 because we've got 6 hours in the sun. Now, this is where you've got to be a little bit careful. The volume axis, the v-axis, it doesn't start at 300 and go down to 0. It starts with 300 millilitres in the dish, but it doesn't start at 300. So what we need to do is we need to recognise we're starting at 1. Next square I'll go up 50, then 100, 150, 200, 250 and 300. Each square is going to represent 50 millilitres of water. And I'm up to 300, which is good because that's how much water is in the dish when I start. I'm going to plot that now. So at time 0, there's 300 millilitres in the dish of water. After 1 hour, so go out 1, I go up to 250. Out to 2, up to 200. Out to 3, to 150, out to 4, up to 100, out to 5, up to 50, and out to 6, I'm at 0. Then I go to join them. My line looks something like that. So there is my graph of plotting my points from the table. Now, part C says, write down the rule. Again, I've got 2 choices for writing the rule. I can use my table or I can use my graph, and I'll show you both ways again. You don't have to do both ways. Do whichever way you think is going to be the easiest for you. But if I look at the table, what is my y row, which is now a v row? What is it going up by? Well, it's not actually going up. It's going down by 50 every single time. If it's going down by 50 every single time, that means m is equal to minus 50 because it's going minusing 50 every single time to get the next number. I've got to go to 0. What's underneath my 0 in my x-axis or my time axis? There's a 300, so b equals 300. Now I know the rule is y equals mx plus b, which is y equals minus 50x plus 300. But I don't have a y-axis. My y-axis is v. I don't have an x-axis. My x-axis is t. I know that from over here. So there is my rule. The volume of water in the dish is equal to minus 50 multiplied by the time plus 300. Now that's using the table to get it. If I wanted to use the graph to get it, I could do the same thing. I need to pick 2 points. It doesn't matter which 2 points I pick. I might pick 2 points at the bottom here. You could pick any points, it doesn't matter. Now acrossways, I've gone across from 5 across to 6, that's 1 unit. Upwards, I've gone from 0 up to 50, that's 50 units. So m equals the rise over the run, which is 50 over 1. But this line from left to right is going down the page, so it's minus 50 over 1, which is minus 50 if I cancel it down. And where does my pink line touch the vertical axis? Well, it touches it at 300, so the y-intercept is 300. So y equals minus 50x plus 300 if I use the rule y equals mx plus b. And that's the same answer as what I had when I used the table. So my rule is volume equals minus 50t plus 300. Now, part D says, use your rule to find the volume of water in the dish after 4.2 hours in the sun. Well, the formula's minus 50 times the time plus 300. Notice I put a times sign here. Minus 50t means minus 50 times t. You don't have to put the times sign there, but you need to understand that minus 50t means minus 50 multiplied by the time. For this question, it's going to be in the sun for 4.2 hours. So you get your calculator and you type in minus 50 times 4.2 plus 300, and if you do that you'll get an answer of 90, which means that if the dish is in the sun for 4.2 hours there should be 90 millilitres of water left in the tank, and left in the dish. Let's just check that. If I went out to 4.2 hours, now I know where 4 and 5 hours is, I'm going to guess 4.2 hours is about there. If I go straight up to hit my pink line, then I go across from there to see where it's going to be. Yeah, that's at about 90, so that'd be pretty close. Now, part E says, use your rule to find the time taken for the volume to reach 75 millilitres. Well, my formula is this. So if I want the volume to be 75 millilitres, that means the volume is 75. So now I need to do a little bit of algebra. So I'm going to minus 300 to both sides. And if I minus 300 to both sides, I'm going to get 75 take away 300 is minus 225 equals minus 50t. The whole idea is to get t by itself because I want to know what the time is. So I'm going to divide both sides by minus 50 because the t is being times by minus 50, and the opposite of multiplying is dividing. Now when I do that, the minus 50s will cancel each other out. I'll be left with t on the right of the equal sign. What's minus 225 over minus 50? Well, if you put that in the calculator, you'll get 4.5. So the time is 4.5 hours. If the dish was out in the sun for 4.5 hours, then we would have 75 millilitres of water left in the dish. And if I wanted to quickly check that, I could do that. The question says to reach 75 millilitres. So if I come across where's 75 millilitres, it's, well, 50, 100, 75 would be halfway between 50 and 100. I go across to my line, I drop down, and the line that drops down is halfway between 4 and 5, which would be 4.5 hours. Time for you to try doing this. As always, it is maths, so enjoy. Bye for now.